In this video, I'm going to show you how to expand logarithms or contract them and simplify them. So let's start with question A. So when you have a division, I'm thinking about this as a log base b of this entire thing. And when you have a division, you could split it up as a subtraction. So this is really just log of base b of the top. So that's the x, the fifth root of x, minus log base b of y to the third z square, right? So that subtraction, that division symbol, that fraction bar, really just turns into that minus. All right, but the base remains the same. Now this over here is really a multiplication, y to the third times z squared. But when you're multiplying, you could write that as an addition. So this is really just log base b, the fifth root of x, minus log base b, y to the third. All right, let me just put this in parentheses just to make it, visible. Plus log base b of z square. Now the other thing you should know is when you have an exponent, you can kind of just pull it out and put it right in front of the log. So this square could come out and put it right in front of the log. Now this here, now I'll just write this on the side. If you have a square root, there's an invisible 2 that's usually there. And you have to think about all of this to the first power, right? So I'm kind of assuming that you know this already, but x squared is really just x to the half power. So you kind of have to do the same thing with this. Now, the only difference is that there's a 5 here. So this is really saying x to the 1/5 power, right? That's what this piece really is here. So let's kind of just erase that and write that as x to the 1/5. X to the 1/5 power. So now we can just take this, put it right in front. So let's do that. That's 1/5 log base b of x minus 3 log base b, all of them are to the same base, of y, plus 2 log base b of z. And that's your final answer. I don't think we could expand that anymore. Let's do b. Now b is going in the opposite way. They give you the whole thing. They want you to put it back into something like this. So let's see. Let's change that subtraction into actually let's put this 5 right back as an exponent here. And then let's change the subtraction back into a fraction. All right, so let's do the exponent first. So log base, or by the way, they must have the same log, the same base, and they do. X squared minus 1 minus log, same base as that one, x plus 1, and that is to the 5th power. Okay, now let's take that minus, put it right back as a fraction. So this is log base 4, big parentheses. Now that first one goes on the top. It's written in the order that the fraction is in. X plus 1 to the 5th. And there that is. Let's see. How else could we do this? Is there anything that we could use? Is there anything that we could do to make this a little bit more compact? Trying to think. And I know this top piece over here could be factored, and I'm not sure about that. Yeah. Let's see if we could do something with that there. So it's a log base 4. The top part is the difference of perfect squares. And if you don't know what that is, definitely look up the difference of perfect squares. That just means when you are factoring something and the first thing is a perfect square, the second thing is a perfect square, and it's a difference, which means you're subtracting them, you could factor it into something that looks like this: x plus 1, x minus 1 over. Now I know that this is an x plus 1, so you can cancel out with that. So I'm just going to write it like this: x plus 1 times x plus 1 to the 4th power, right? Why didn't I just write them out 4 times? Well, because the only thing I really want to do is cancel those out. So you remain with log base 4 of x minus 1 over x plus 1 to the 4th. And I don't think we could do anything else with that, so we'll leave it just like that.